Everyone, this is the first of a few videos that I'm going to post up about going through the revision notes. I know we've done some of it in the lesson already, but I'm just going to go through all of the questions, basically, spend the stuff that you do at home. You can have a look how you've done, pretty much. All right, so these are the answers that we're going to go through. All right, so starting them off. Generating sequences. I won't spend too long on the ones that we've already gone through, all right, but I know some people missed the lesson as well. So this says calculate the first 5 terms in the sequence with the nth term 5n minus 7. Right, so we just need to remember first 5 terms means the first 5 numbers, okay, and all those numbers is going to be the answers to when n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. Okay, so it is literally substituting these values of 1, 2, 3, 4, and 5 into this equation, right? And lots of you are clever enough to work those out in your head anyway without much workings. All right, so the first term is 5 times by 1, take away 7. Then it's 5 times 2, take away 7, and then up to 5 times 5, take away 7. Okay, so each of those answers, then you should notice the pattern as well. Because it's 5n, you should notice that the pattern of numbers is going up in 5s. Okay, so 5 times 1 is 5, obviously, take away 7. Minus 2, 5 times 2 is 10, take away 7 is 3. Okay, 5 times 3, take away 7 is 8. And 13, 18. Okay, so your pattern is going up in 5s because it's 5n. So the sequence then, the first 5 terms in that sequence, just write them in a list. Minus 2, 3, 8, 13, 18. And that carries on going. All right. So pretty straightforward, done in plenty of times. Moving on. Okay, so this one now, first 5 terms again. All right, so the first 5 numbers in the sequence. This time it's 20 minus 3n. So this minus 3n part here, this should indicate to us that it's going down by 3 this time. Okay, so same thing, right? The first one, when n equals 1, is 20, take away 3 times 1. Then 20, take away 3 times 2. Okay, up until we've done n 5 times. So 3 times 3. 3 times 4, 3 times 5. Okay, so 20 take away 3, 17, 20 take away 6, 14, 20 take away 9, 11, 20 take away 12, 8, 20 take away 15, 5. So that matches up to what we expected here, and there's going down by 3 each time. So write those out in a list: 17, 14, 11, 8, 5, so on. Okay, so that's generated in sequence using the nth term. So moving on then, we've looked at questions. Oh no, sorry, it's not moving on. It's still the same thing. So this time, my bad. First 5 terms and n squared minus 7. So this time we're still swapping n for the numbers 1, 2, 3, 4, and 5. Okay. It's not going to go up or down by the same amount this time. It'll go up by a different amount, but you will still see some sort of pattern as you go through. Just be careful with this one, all right? I shouldn't have to say this to this class, but make sure that you're doing squared correctly. Yeah, it means times by itself. It doesn't mean times by 2. Okay, so the first one is 1 squared minus 7, then 2 squared minus 7, up to, that's wrong. Up until you've done 5 squared. Okay, so 1 squared is 1, minus 7 is minus 6, 2 squared is 4, minus 7 is minus 3, 3 squared is 9, minus 7 is 2. Okay, 4 squared is 16, minus 7 is 9, 5 squared is 25, minus 7 is 18. So our sequence is minus 6, minus 3, 2, 9, 18, and so on. And we've done this type before anyway. You should notice now that it goes up by 3 in the first instance here. Okay, it goes up by 3 here. Then it goes up by 5, then 7, then 9. So it goes up by an extra 2 each time. So the next one would go up by 11, 13, and then so on. Okay. So really simple topic. Make sure when it's squared, you remember what squared means. It's always times by itself. Okay, now moving on to finding the nth term. So this is doing it the other way around now. But thinking back to the rules that we just said about the number in front of n. So this time we're given the sequence and we've got to find out the nth term, which just means the rule, doesn't it? So what you should be looking for these questions is there a common difference? So do the numbers go up by the same thing every time? Okay, if they do, which they do in this case, it's add 11 each time, isn't it? So in each term you add 11. Okay, the question is not asking for what's the next number in the sequence. It's asking for the nth term. Okay, so whatever number it goes up by, that's the number that goes up. Goes up by 11, so the number in front of n is 11. Okay, so similar to the first question that we just went through, it was 5n, it went up in 5s. So this number in front of n is what it goes up by. All right, and then it's usually an add or subtract on the end of this rule now. Okay, so remember that the first term in the sequence is when n equals 1. So if you want to work out what goes on the end now, you start with this 11 and figure out how you change that 11 into the number 8, which is the first term in the sequence. Okay, so to go from 11 to 8, you subtract 3. So your rule is 11n minus 3. And just double check that that works for one of the other terms as well. Like if I pick this term, for example, this is when n equals 4 because it's the fourth term in the sequence. So 11 times 4 is 44. Take away 3 is 41. So that works. That's the rule. Okay, so find the common difference and then work out what goes on the end of the rule afterwards. So next one, still doing our common difference, right? So still looking for whether it goes up or down by a certain amount. So if we look at these values, you should notice it's going down by 5 each time. So our rule will start with minus 5n. Okay, and then still the same principle in terms of working out the end number now is how do we go from this minus 5 to the first term in the sequence. So use a number line if you're unsure, or think of a number line in your head. We're on minus 5 and we're trying to get all the way up to 11. Okay, so add on 5 to get to 0, add on another 11 then to get to 11. So that's adding 16 in total. And then the same as we've done earlier on then, we think that's our answer. Let's just double check it. So I'll do this one, where n equals 3. Okay, so if n equals 3 there, then minus 5 times 3 is minus 15. Minus 15 plus 16 is definitely minus 1. Or it's definitely positive 1, sorry. So that's it. That's the answer. So you know that that works for that question. Okay, and then last one for this section now. Sometimes it doesn't go up by the same amount. So if we have a look at what is happening here, all right, it goes up by 3, then 5, then 7, then 9. So whenever the difference is not common, so it doesn't go up or down by the same amount, like we've already seen earlier on anyway, where we did it the other way around, it's got to be n squared. Okay, so this time, when we're working out what goes on the end now, in a plus or minus, we've got to remember that we're squaring n first. So n is 1 in this first term here for the 5. Okay, so 1 times 1 is 1. N is 2 in the second term. 2 squared is 4. N is 3 in the third term. 3 squared is 9. 4 in the fourth term. 4 squared is 16. And then 5 in the fifth term. 5 squared is 25. Okay, so our rule now is have a look at those numbers I've written along the top and how do we go from the number 1 to the number 5, for example, 4 to 8, 9 to 13, 16 to 20, 25 to 29. It's obvious that it's plus 4. Okay, so if it's an n squared question, then make sure that you're using your square numbers and you're working out how you change the square number into the number that's in the sequence. Okay, so moving on. Solving inequalities now. So solve them in the same way that we would solve it if it was an equal sign there. Okay. So this equation in particular has got the unknown on both sides, or x on both sides. So remember, when that's the case, you've got to take away the smallest x of mu or get rid of the smallest x, whatever you want to call it. So for this question, got 2x on one side, 7x on the other side. 2x is the smallest, so we're going to subtract it. Okay, so if I subtract 2x from both sides now, I get 59 left on this side. This greater than symbol stays the same. I haven't got 7x anymore, so we're taking 2x away from it, so that's 5x, and then we got plus 9 on the side then. Okay, so 59 is greater than 5x plus 9, and we're just solving in a normal way that we would now by working backwards. So because this says plus 9, we're going to subtract 9 from both sides instead. Okay, so this side will be 50, because that's 59, take away 9, isn't it? Is greater than 5x, and then 5x means to times by 5, so the opposite is to divide by 5. Okay, so 50 divided by 5 is 10. So this is saying now that 10 is greater than x, or you can write x is less than 10. Okay, just note that if you are going to rewrite it like I've done here, at the end you've got to swap the symbol over. Okay, you can't write x is greater than 10, because 10 is greater than x, which means x must be less than 10. And also have a think about what values could work for x now. X can't be 10, all right, because it says it's got to be less than 10. So it can be any number less than 10, but not including the number 10 itself. Okay, next one. So still an inequality for this one. It looks a little bit different. Your starting point doesn't really make a difference. So you can either get rid of the 10 first, or you can get rid of the minus 5 first. It makes no difference. Okay, I'm going to get rid of the minus 5 first. Okay, I'll take it to the other side, whatever you want to call it. It's a minus 5 at the moment, so we make it a plus. So we're adding 5 to both sides. Okay, so we've got x over 10 is less than or equal to 3 plus 5, which obviously is 8. And then from there, don't overcomplicate the question. X over 10 means divide by 10, doesn't it? Because a fraction line means divide. So the opposite of dividing by 10 is multiplying. So x is less than or equal to 8 times 10, which is 80. And then understand what that inequality means as well. So x can be less than or equal to 80. So meaning it can be 80 or less. Yeah. Okay. So I'm going to stop this video there because it only records for a certain amount of time, and I'm going to carry on a separate video. Okay. Okay, next section of the video then. So we finished at section 3. So solving equations containing fractions. All right, so 2 questions for this one. So first thing to remember, obviously it says plus in between these 2 fractions here. Look, so just remember your normal rules for adding or subtracting fractions is to make the denominators the same. Okay, so at the moment there's no denominator on this one, so we make it into 1. Okay, and then we're looking for the smallest number that 1, 2, and 5 all go into, which in this case is going to be 10. Okay, so we're going to make this into something over 10 and this into something over 10. Okay, so looking at each fraction separately then, in this first fraction the denominator was 5. So to make that denominator into a 10, we've times it by 2. So we have to times the top of the fraction by 2 as well. And I'm going to use a bracket. Okay, so 2 times by x plus 2 is 2 bracket x plus 2. Then the second fraction, okay, it was a 2 on the bottom. We've made it into 10, so we must have times it by 5. So we times the top by 5 as well. So that's going to be 5. Make a bit more space. So that's going to be 5 bracket 2x plus 3, close bracket. And then on the other side of the equal sign then, don't just leave it as 4, which is a common mistake. Okay, it's 1 on the bottom. If we're making that 1 into a 10, we're timesing it by 10, aren't we? So we have to times the top by 10 as well. Okay, so that's step 1. Work out your common denominators and figure out what you've times each fraction by. And remember, whatever you times the bottom of the fraction by, the top of the fraction has to be times by the same amount. Okay, so from here now, we can get rid of the bottom. They cancel each other out, because if we multiply both sides by 10 now, there'll be no 10 on the bottom. And we're going to expand the brackets as well. Okay, so here I've got 2x and 4. 2 times x is 2x, isn't it? 2 times 2 is 4. So we get 2x plus 4. And the same for the next bracket then. So 5 times by 2x is 10x. 5 times by 3 is 15. And that equals 40. Okay. So the next step from there, don't try and solve it yet. Collect the terms that are the same. So make it easier. Collect the like terms. So you've got 2x plus 10x, which is 12x in total. You've got 4 plus 15 there, which is plus 19. Okay, that equals 40. Then we solve the equation, don't we? So we're working backwards to find the value of x. So take away 19 from both sides, first of all. We get 12x equals, and then 40 take away 19 is 21. And the next step from there then, we don't want 12x, we want 1x. So we divide by 12, and I'll finish it off over here then. So we get x equals, and I know the 12 doesn't go into 21. Okay, so write it as a fraction instead, 21 over 12. Doesn't really matter whether you change that into a decimal or not. You can simplify it though if you divide by 3. So that would be 7 over 4 if you wanted to simplify it. But that's it. Okay. So make the denominators the same. Expand, collect like terms, solve. Okay, next one then is subtract this time, all right? So we still have to make the denominators the same. This time there is a denominator already on the term that's after the equal sign. Okay, so this side and this side need to be the same denominator. In this case, it's going to be 6, isn't it? Because the smallest number the 2, 3, and 6 go into is 6. So we'll do that. So this first fraction was a 2 on the bottom. We've obviously times it by 3 to make it 6. Okay, so we times the top by 3 as well, using a bracket. So 3x minus 2. Oh, I've done it again. Even that room. Okay, then we've got a minus then, and then this second fraction was x over 3. So the 3 has been made into 6 by timesing it by 2. So we're going to times the top by 2 as well. So that's going to be minus 2x. There's no need for a bracket on that one, is it? Because it's just x times 2. And then at the end, after the equals, it's just a 5 because we haven't changed the denominator for that part, so it just stays as it is. Okay? So then we do the same thing as last time. If we were to multiply both sides by 6 now, the bottoms would sort of cancel each other out. So we're going to expand this bracket now. We get 3 times 3x is 9x. 3 times minus 2 is minus 6. And then just got minus 2x on the end there. Okay. Collect together any terms that you can that are the same. So in this case, we've got 9x minus 2x. Okay, so take account of the minus symbol. So 9x take away 2x is 7x. Minus 6 equals 5. And then we solve. So I'll carry on over here again. But this says minus 6. So we would add 6 to both sides, wouldn't we? So we would get 7x equals 11. Because 5 plus 6 is 11. Okay. And then 7x means the times by 7, doesn't it? So we divide by 7 instead. And again, 7 doesn't go into 11, so write the answer as a fraction. Okay, we can't simplify that one, but that's it. 11 over 7 is the answer. Okay, right, moving on, because that's pretty much what we got up to when we were doing it in lesson anyway. So it's a few simultaneous equations, and we've already covered this year when we were recapping the work from year 9. Okay, so solve the following using algebraic methods. So the first thing we have to try and remember for this one is we number them at 1 and 2. Okay, we need to make either the x terms or the y terms the same value. Okay, and in this case, if we can do it just by multiplying one of the equations, so just do it that way. So if we wanted to make the x's the same, the smallest number we could do is 50, which means you'd have to times both equations. All right, it's easier if we make both of the y's the same. We can do that just by timesing the first one by 2, can't we? Because we make it 2y. But remember then, when you're timesing it by 2, every term in that equation needs to be multiplied by 2, so you'll end up getting a new equation. Okay, so you can't just write 3x minus 2y equals 10 because it won't work. So we're timesing everything by 2. Okay, so our new equation will be 6x minus 2y equals 20. Okay, and I'm just going to rewrite equation number 2 underneath now. Okay, so 5x plus 2y equals 24. Right, so that is always step 1, is either to make one of the coefficients the same number, yeah? All right, so we've done that now. Now we need to remember our rules with the symbols. So the rule is, remember, same sign, subtract. In this case, we don't have the same signs, okay? We have 2 signs that are different, which means we're going to add instead. So we're going to add these 2 equations together, okay? So they're on top of each other, just do the column method, and there's 6x plus 5x is 11x. This is always going to make 0, all right, because we're doing minus 2 plus 2. That's the whole point of us making them the same in the first place, is so they will make 0. So there's nothing to write there. And then 20 plus 24 is 44. So 11 times by something is 44. X is 4. Okay. And when we did this before, lots of us were okay with those first steps. It was a substituting that we were making a couple of mistakes on. So now that we know that x equals 4, we need to sub x equals 4 into one of our 3 equations, okay, to work out what y is as well. When we're doing this, try and do the easiest one possible. That's usually the one with the least amount of x. So I'm going to sub x equals 4 into equation number 1 for this one. Okay, so instead of writing 3x, we know that x equals 4 now. Okay, so 3x here in equation 1 becomes 3 times 4. Okay, so we're doing 3 times 4 minus y equals 10. We know that 3 times 4 is 12. Okay, so this equation now is saying 12 take away something equals 10. Okay, so obviously you take 2 away from 12 to make 10. So y must equal 2. So our solutions, x equals 4, y equals 2. Okay, and if you want to check whether those solutions are correct, then put them into equation number 2, but we didn't use that one originally. All right, so if x is 4, we're saying 5 times by 4 is 20. All right, and then 2 times by 2 is 4. 20 plus 4 is definitely 24. So it works. Those are the correct answers. Okay. Right, next one then. So similar sort of thing here. Look, the values are not the same for either P or Q, so we make them the same. Doesn't really matter which one we do this time because we're going to have to multiply both of them. Okay, I'm going to make the Q's the same because we normally do the second term anyway, just to make it a little bit easier. So that's what we're going to do. So the smallest number 3 and 2 go into is 6. So I'm timesing the first equation by 2, timesing the second equation by 3. So I'm going to get 2 new equations. And remember, timesing each of them by 2 and 3. That means every term in there is times by the same number. So everything times by 2 in the first one would give us 8p minus 6q equals 46. All right, and then everything multiplied by 3 in the second one will give us 9p minus 6q equals 51, I think. Yeah, 10 times 3 and then 7 times 3. Okay, so these are our new equations now, number 3 and number 4. Now we've made one of the values the same, we can try and figure it out from there. Okay, so this time, both of the symbols are the same. Okay, they're both minuses, so when the signs are the same, we always subtract. So we're going to subtract these 2 equations from each other now, but you don't always have to subtract them in the way that they're written. It would be easier for this one if we did equation number 4 first and subtracted equation number 3. So I've got 9p in the first one and 8p in, so I've got 9p in equation 4, sorry, and 8p in equation 3. So 9 minus 8 is 1, yeah, just p. Remember, the 6q's make 0, and then 51 take away 46. is 5. Okay, so P equals 5. Then we're going to, same as last time, sub P equals 5 into one of the equations. Easiest one to do in this case would be number 2. It's the smallest amount of P. Right, so now that we know P equals 5, where this says 3P, we don't need to write that. That means 3 times by P. So in this case, 3 times by 5. Okay, everything else is the same in that equation then. So minus 2Q equals 17. So we're saying 15 minus 2Q equals 17. Okay, and then don't overcomplicate this one now. This is saying 15 take away something equals 17. All right, so the only way we're going to be able to go from 15 up to 17 by subtracting is if we use a negative in there, because 2 negatives make a plus. Okay, so all this means is 2Q must be minus 2. Yeah, because 15 minus minus 2 is 17, because it becomes 15 plus 2. So Q must be minus 1, because obviously we divide minus 2 by 2. All right, so our two solutions are P equals 5, Q equals minus 1. And if you check that, let's check that in equation number 1 now. Okay, so 4 times 5 is 20, and then minus 3 times minus 1 is minus 3. So that works, doesn't it? Because we get 20 plus 3 equals 23. Job done. That's the answer. All right. So run out of time now for this video. All right. So I'll stop this one there and carry on with the separate ones. Okay, next one then. So carrying on with simultaneous equations. This looks like a hard one, but once you break it down, it's not too bad. All right. So Baz, Cass, and Shaz visit the same food store. Blah blah blah. The simultaneous equations you can make just from these two sentences here. All right, so Baz buys 4 kilograms of raspberries and 5 kilograms of black currants for a total cost of £38. So 4 kilograms of raspberries, all right, we'll call that 4R. 5 kilograms of black currant is 5B. Okay, and the total cost of £38 just means it equals 38. So you just got to form the equations yourself first and then solve them afterwards. Okay, so then for Kaz, she buys 6 kilograms of raspberries, so that's going to be 6R, isn't it? And 3 kilograms of black currant, so that's plus 3B, and that equals 39. Okay, so from there then, same rules apply as they did in the other two questions as well. So we need to make some of the values the same, either R or B. All right, I'm going to stick with the second term in the question. All right, so I'm going to make B the same. So smallest number, the 5 and 3 both go into is 15. So I'm going to times this one by 3 and this one by 5, and we'll get our two new equations. Okay, so this first one now will become 12R plus 15B equals, and then 38 times 3 is 114, I think. So that's that one. All right, times in the next one by 5 then. So 6R times 5 is 30R. 15B, which is what we were trying to do. And then 39 times by 5, 195. Okay, so we've got our two equations. The 15s are the same. The signs are the same, look, so we're going to subtract, okay, but let's do it as 4 minus 3, because we don't want to really be using any negatives, do we? So we're going to do 30R take away 12R, okay, yeah, 30R take away 12R, which is 18R, and then we're going to do 195 minus 114, which is 81. Okay, so if 18R equals 81, then R will equal 81 divided by 18. Okay, you can use calculators anyway, that's 4.5. All right, well, because we're talking about money, in this case, £4.50. Okay, so 1 kilogram of raspberries is £4.50, we just worked out. Now we still substitute that value in, because we know what R is now, we substitute it in to find B. Okay, so I'm going to sub R equals £4.50 into, I'm going to do equation number 1. Okay, it's the smallest amount of R. So instead of writing 4R, we know that means 4 times R, so 4 times 5, 450. Okay, everything else in that first equation is the same now, so plus 5B equals 38. Okay, so 4 450s is 18, so this is 18 plus 5B equals 38. Take the 18 away then, so 5B equals 20, B must equal 4. Right, so that's just solving the equation, but on this question there's a little bit extra for us to do as well, so make sure you read it carefully. So use the algebraic method to find how much Shaz pays in total for 5 kilograms of raspberries and 7 kilograms of blackcurrants. Well, now that we know the price of each of them, okay, we're saying 1 kilogram of raspberries is £4.50, 1 kilogram of blackcurrants is £4. Okay, so Shaz is buying 5 kilograms of raspberries, so she's getting 5 lots of £4.50. She needs to pay that much, doesn't she? And then she's buying 7 kilograms of raspberries, so that's 7 lots of 4. Okay, so then when you add those together, then 5 times by 450 is £22.50. 7 times by 4 is 28. So when you add those together, then she is spending £50.50 to get the 5 kilograms of raspberries, 7 kilograms of blackcurrant. Okay, so quite a lot. It looks worse than it is, though. Break it down, make your equations, go from there. All right, moving on then. So changing the subject. All right, changing the subject of the formula. So this says make X the subject of the following formula. Okay, which means we want the formula to say X equals. All right, so the first thing I would do for this one is expand the bracket. All right, so 2 times by 5x is 10x. 2 times by 2w is 4w. And that equals 11w. And think of what you would normally do to solve an equation, which is work backwards in there using inverse operations. This is the same thing, but instead of having an answer that's a number, we're going to have an answer that says X equals and then some algebra. Okay, so you need to get rid of all the other terms on one side apart from X. All right, so here you want to get rid of this plus 4w, then taking it to the other side or doing the opposite would be to subtract, wouldn't it? So we would get 10x equals 11w take away 4w is 7w. Okay, and then we don't want 10x to be the subject, we just want x to be the subject. Okay, so to get rid of the 10, remember 10x means the times by 10, so we would divide by 10 instead. All right, so we would end up with x equals, and then we want to do 7w divided by 10. So remember to use a fraction, isn't it? So 7w on top, 10 on the bottom. So x equals 7w over 10. And I've said this before to you as well. Sometimes the answers will look a bit confusing, but we're not actually using it. We've just made x the subject. That's what the questions asked us to do. So we move on. Next one. Okay, so still making x the subject for this one. All right, there's a fraction on this side of the equals to start with, so we want to get rid of that. Remember that fraction means divide, doesn't it? So that means 9x plus 2 divided by 6 minus x. So the opposite of dividing by 6 minus x is to times by 6 minus x. Okay, so we get 9x plus 2 equals, and then 4 times by 6 minus x is 4, and then bracket 6 minus x. Right? There's plenty of us that can do that in one step anyway. I'm going to write it as a bracket and then expand it afterwards, but if you want to do it all in one, that's fine. So we get 9x plus 2 equals, and once we've expanded this now, we get 24 minus 4x. Okay, so we've got x on both sides. We want them all to be on one side to make them a subject. So at the moment on this side, the x is a minus. It's minus 4x. So So when we take it to the other side, it's going to be plus 4x. Okay, so 9x plus 4x is 13x. So we get 13x plus 2 equals 24. All right, so keep going step by step. We want to get rid of the 2 now. So we get 13x equals 24 minus 2 is 22. And I'll carry it on over here then. Okay, to make x the subject, we want to divide by 13 and we get rid of the 13. So x equals 22 over 30. And that's it. Okay, next one. So similar sort of thing now with the 6 minus x on the bottom. So step 1, same as last time, is going to be to times by 6 minus x. So 9x plus 2 equals 4e brackets 6 minus x. Then we'll expand the bracket. So 9x plus 2 equals 4e times by 6 is 24e. 4e times by minus x is minus 4ex. Right? So this time, making x a subject, we still need to get this minus 4ex over to the other side, don't we? So it's a minus at the moment. We're going to make it a plus instead. So we've got 9x plus 2 plus 4ex equals 24e. Okay. Now, on this side, we've got 3 different terms here. Look, 2 of them contain an x. Okay, the plus 2 doesn't, so we want to get rid of the plus 2. So the opposite of adding 2 is subtracting them. So we're left with now 9x plus 4ex equals 24e minus 2. All right, and then from there, we've done a couple of these before. So there's an x in both terms. The only way we're going to get rid of all the other things that are attached to that x is if we factorize. But we can only factorize because there's an x in both terms. Okay, so we're going to factorize this side now. So the thing that's common in both of those terms is x. So when I carry on over here, okay, the thing that's common in both terms is x. So x goes on the outside of the bracket. So to make 9x then, you would times by 9, and to make 4ex, you've already got the x, so you times by 4e. And then 24e minus 2 stays the same on the other side. Because now this means x times by the bracket. So the opposite of timesing by the bracket is to divide. So x will equal 24e minus 2, all divided by the bracket, which is as a fraction. So divided by 9 plus 4e. Okay, and you don't need the bracket on the bottom anymore. If you write it, it doesn't make it wrong, but there's just no need for it. Okay, so sometimes you have to factorize to be able to make to be able to change the subject. So if you end up with terms that have got the same thing in them, so something common, which in this case was x, then you do it that way. Okay. Right. Yeah, I've just got enough time on this video to quickly do this as well, and I'll have to stop and do a separate one. Okay, so expand and simplify. This should be easy. Just try and remember that the best way that we've done it before, or the way we've learned it, is the box method, because we all know how to use the box method anyway. Okay, so 6x times by 2x is 12x squared. 2x times by 5 is 10x. Minus 3 times 6x is minus 18x. And minus 3 times 5 is minus 15. So you've got to get your symbols right for this one. Okay. Then we collect together the terms that are the same, which is usually these x's here. So for the first one, we've got 12x squared. Okay. And then minus 18x plus 10x, or 10x minus 18x, either way, should give you minus 8x, and then minus 15 at the end. Okay, draw a number line or think of a number line in your head if you're unsure when you're collecting these terms together. Okay, so that's that for that one. Next one. So this has only got one bracket, but remember squared means times by itself, doesn't it? So this is the same as writing 4x minus y, and then the same thing again. So be careful when this comes up in a test, it's trying to catch you out. So box method, 4x minus y, 4x minus y. And then we go for it in the same way. So 4x times 4x, 16x squared, 4x times minus y, minus 4xy, 4x times minus y, minus 4xy, minus y times minus y is y squared. Okay, not minus y squared, is it? Because a minus times a minus gives you a plus. So you can still collect together the terms that are the same now. But when you do this, we've got 16x squared. Okay, and then here we've got minus 4xy minus another 4xy, which should give you minus 8xy. Okay, minus 4, take away another 4, and then the y squared on the end. So that is your answer. So expanding the double bracket is easy. Just use the box method. Careful when you're collecting together the terms that are the same. Right, so I'll stop there for that one. Okay, next one then. Carrying on from where we left off, so factorising it, right? Factorising quadratics. So this one, we've got 3 terms, okay, and there's only one x squared at the start, because remember, x squared on its own just means 1x squared. So this is where we're just factorising into 2 brackets, okay, so the only way you can get x squared is x times x. In this case, okay, they're both positives in the expression, so they're both positives in the brackets, and then we're looking for 2 numbers, the times to give us 10, and they'll add to give us 7. Okay, and it's a fairly easy one to start with, all right, it's 5 and 2, or 2 and 5. But if you're ever unsure, it's this n term that will help you the most. So list your factors of 10. Okay, the only way you can times to make 10 is 1 times 10, or 2 times 5. So once you've done that, it's obvious that the only pair that's going to give you 7 when you add them together is 2 and 5. Because the symbols are the same, you can have those in any order that you want. Okay, so x plus 5 and x plus 2. Moving on. So this time, still 3 terms. Okay, we've got x and x, definitely, to make the x squared. We're still timesing to make this end term, and adding to make the middle term. Okay, but this time, the symbols are not going to be 2 pluses. All right, we're multiplying to make a plus 6, but we're adding to make a negative 5. So the only way that's going to work, okay, if you think back to this table that we've done quite a few times, all right, we're multiplying to make a positive answer. So that means it can either be this one or this one. Okay, there's no way by using 2 pluses we're going to get a minus answer. So it has to be this one. Okay, 2 minuses. All right. So that's a minus, and that's a minus. And then if you're unsure, list your factors of 6. It's 1 times 6, 2 times 3. The only pair there that's going to give you 5 is 2 and 3. And again, because the symbols are the same, have them any way you want. So either x minus 3 and then x minus 2, or what I've written there. Okay. So if you quickly expand that then, all right, the minus 2 times minus 3 gives you this plus 6 at the end. The minus 2 minus 3 gives you minus 5 in the middle. So be careful with the symbols. Right, this is one then that I've set you before to do at home, and some of us struggled with it, okay. The MathsWatch version, it's a slightly different method to the one I'm going to show you now. Okay, so with this, when we normally expand double brackets like we did in the last section, we use the box method. Okay, so we know that this is going to be 2 different brackets. Okay, and to work it out, the only way that we're going to be able to get 2x squared is by doing 2x times by x. All right, so it has to be 2x times by x. The symbols are the same, both pluses. So they're both pluses in the answers. Now we just have to think a little bit more about the numbers at the end. All right, so I'm just going to set the box method up over here, and we'll do like a little bit of trial and error if we need to. So it's got to be 2x and x, okay? And then we're looking for still 2 numbers at times to make 15, okay? So they're both positive, so that needs to be a plus, that needs to be a plus. And when we work this out now, 2x times x is x squared, and it's a positive 15 at the end. Okay, so two numbers of times to give us 15, and they will add in the middle to give us 11. So think about it a little bit if you're unsure. Yeah. For this one, the numbers that we can times to make 15 are only 1 and 15, or 3 and 5. Okay. So 3 and 5 would work. Just have to get them the right way around. So just do trial and error. I'm going to put plus 5 here and plus 3 here, and just see what these two terms end up being. Because if when we add those together we get plus 11x, that's fine, they're right. And if we don't get plus 11x, then it means the 5 and the 3 just need to be the other way around. So just trial and error. Try one, see if it works. If it doesn't, swap them around. So if we were doing this now, in here would be 5x, wouldn't it? Because that's 5 times by x. And in here would be 6x, because that's 2x times 3. If you collect those together, you do get the 11x that's in the middle there. Okay, so that means they're the right way around. So this is your first bracket here. This is your second bracket here. So the answer is 2x plus 5, and then x plus 3. Okay, so that worked. It might not always work first time, every single time, but it worked for that one. Okay, moving on. This one now, still more than 1x squared, so we're going to use the same method, right? So we know it's going to be 2 brackets. The only way we can make 3x squared is by doing 3x times by x. Okay? So this end term now is a minus 7. So we're still timesing to make that end term, right? But the only way that we can multiply to make a minus is by using 2 different symbols. Yeah, a plus and a minus times together gives you a minus, isn't it? Okay? So from there then, we just need to get the values the right way around. So set the box method up. We know it's going to be 3x plus something, and we know it's going to be x minus something. Okay, 3x times x is 3x squared. We know that this end term has to give us minus 7. Okay, so the numbers are a little bit easier this time because the only numbers you can times to make minus 7 is 1 and 7, isn't it? But you've got to get them the right way around. So let's just try one, see if it works. I'm going to put 7 here and 1 here and see what happens. All right, so x times by 7 is 7x. 3x times minus 1 is minus 3x. So if we were to collect these two together now, we wouldn't get the plus 20 in the middle, which is what we need. Okay, so that tells you for this one that those can't be the right numbers. So let's try them the other way around. So instead of plus 7 and minus 1, let's do plus 1 and minus 7. So plus 1 there, minus 7 there. Then work it out. So x times by 1 is x, and minus 7 times by 3x would be minus 21x. Okay, so now when we collect these together, we do get the 20 that we're looking for. Yeah. Okay. So what we may have to do though is what you should notice is minus 21 plus x gives you minus 20. We want plus 20. So let's just swap the symbols around. So it is just a little bit of trial and error. But figure out the numbers first. Yeah. And then just have a play around with what the numbers would be. That works now. 21x minus x. So this is change as well. So 3x minus 1, x plus 7. Okay? And that's how we do that one. Okay, moving on, more factorising. This one looks harder than it is, okay, because there's only 2 terms and we're used to there being 3. But this is called the difference of 2 squares, and that's because 100 is a square number. So this will only work with a square number. So even though there's only 2 terms, we can still do 2 brackets, okay? So we're looking for 2 numbers of times to give us 100. Right? One's a plus and one's a minus, because That's the only way we can multiply for a minus, isn't it? And really, there's no x term in the middle, which just means there's 0x, which means the numbers we use now are going to be the same. All you've got to do is remember that's a square number. Just do the square root of 100, which is 10. So your answer is x plus 10 and x minus 10. Okay, because if you were to expand that now, you'd get x times x is x squared. You'd get 10x minus 10x, which is 0, and you'd get 10 times minus 10, which is minus 100. Okay, so it only works with square numbers. So this one looks harder than it is as well. There's only 2 terms, but this can also still be 2 brackets, because if you look at both of the numbers, they're both squares. Yeah, 9 is a square number, 121 is a square number. Okay, so square root of 9 is 3. That means we got 3x there and 3x there. Okay, 1 plus and 1 minus, because that's the only way we can multiply to make a minus, isn't it? And the square root of 121 is 11, so that should be 11y there and 11y there. Okay, and that's it. If you were to expand now, you get 3x times 3x is 9x squared. The 3x times minus 11y and the 11y times 3x, they will cancel each other out, that makes 0. And then 11y times minus 11y is minus 121y squared. So moving on. This is solving by factorising now, so it's just one added step at the end. Okay, so you still factorise in the same way, only this time it equals something. So we're going to factorise x squared minus 7x plus 12. Okay, so 2 numbers, the times to give us plus 12 and add to give us minus 7. So the symbols have to be 2 minuses. So minus times a minus gives you a plus here. Minus take away something else gives you a minus there. Okay, and if you're unsure, factors of 12, 1 and 12, 2 and 6, 3 and 4. Okay, the only pair there that's going to give you 7 is 3 and 4. So we get minus 3, minus 4. This time it equals 0. And the 2 brackets just means there's 2 separate solutions to this question. All right, so we're saying x minus 3 equals 0. So something take away 3 equals 0. So for this one, x is 3, because 3 take away 3 is 0. For this one, x is 4, because 4 take away 4 is 0. And the best way to remember it like this is the solution to the bracket is just the opposite to what the symbol is. So if it's x minus 3, then x equals 3. If the bracket said x plus 3, the solution would be x minus 3. X equals minus 3, and so on. Okay? And I should have just enough time as well for this video to do the next one, factorising as well. So don't overcomplicate it. Factorise in the same way, then just write your solutions down for each bracket. So x can be 3 or x can be 4 in this case. Okay, so same thing there. We've got more than one x, right? So we need to do the same method that we've done before in the last little section. So the only way we can make 2x squared is 2x times by x. The symbols are both the same, both pluses, so they're both pluses here. Okay, and once we factorised, we're making it equal to 0. So we want 2 numbers that times to make 11. Yeah, it's easier than it looks because the only 2 numbers you can times to make 11 are 1 and 11. So do the box method, set up a little trial and error, see which one makes the plus 13 in the middle. Okay, so we know that that needs to be 11. So let's just see how it works. I'm going to put 11 here and 1 here and see whether that works. And if it doesn't work, we'll just swap the 11 and the 1 over. Okay, so x times by 11 is 11x. 1 times by 2x is 2x. If we collect those 2 together, then we do get plus 13x. So that means that one's right. So it's 2x plus 11 and then x plus 1. Okay, so lucky guess, we got it right first time. So we still got 2 solutions there. This solution, okay, x plus 1 equals 0. So something plus 1 equals 0. So that's minus 1. And for this one, it's a little bit more complicated, but we're saying 2x plus 11 equals 0. Okay, so just solve that equation now. So work backwards until we find out what x is. So if we were solving this equation, to get rid of the plus 11, we would subtract a point. So we would say 2x equals, and 0 minus 11 is minus 11. Yeah? And then 2x means times by 2. So we divide by 2. So we would get x equals minus 11 over 2, or minus 5.5 if you want to write it like that instead. So for this one, we get x is minus 1, or x is minus 5.5. Okay. So I'll stop there for this one, run out of time a little bit. I'll carry on in a separate video. Thank you. Okay, carrying on where we left off then. So quadratic formula. We don't need to remember the formula because it's given to us in the paper. Remember, I'm just going to write it down at the top here though. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. All right. So in the equation then that you're given, a is always in front of x squared, b is always in front of the x, c is there. Okay, and I'm going to write those values down now. So a equals 5, b equals 13, and c equals minus 11. You've got to include the minus because it'll make a big difference to your answer otherwise. Okay, so don't just look at the numbers, look at the symbol that's in front of the numbers as well. So I'm just going to substitute those values into the formula now. So if b is 13, this is going to become minus 13 plus or minus the square root of 13 squared, take away 4 times by 5 times by minus 11, all divided by 2a, so 2 times 5. Okay, I prefer you not to type all that into your calculator. All right, let's just work it out first to see what we get under the square root sign. Okay, so this is now minus 13 plus or minus, so 13 squared is 169. Then we're taking away 4 times 5, which is 20, times by minus 11, which is minus 220. Okay, so we've got one minus here, look, that's that one. And then this answer, so that answer there, gives you another minus, which is that one. Okay, over 10. And then what we should notice is those two minuses give us a plus. So we get 169 plus 220. Which is 389, all divided by 10. Okay, it's important that you get to this part, in my opinion, before you type it into your calculator. Okay, because if this comes out as a minus, so if we did 169 minus 220, so if you forgot about the other minus to make it a plus, you wouldn't get the correct answer. So now we type this into our calculator. All right, once using the plus sign, write your answer down. Once using the minus sign, write your answer down to 2 decimal places. Okay, so plus first, it's minus 13 plus the square root of 389 all over 10. All right, and it says to 2 decimal places. So type it into your calculator exactly as it looks. Yeah, the whole thing is over 10, so use the fraction button. The 2 decimal places for this one should be 0.6. Okay. Then do exactly the same thing, but using a minus instead of a plus. So it'll be minus 13 minus root 389 over 10. And again, type that into your calculator exactly as it is. So minus 13 minus root 389 all over 10 should be minus 3.27 to 2 decimal places. So those are your 2 solutions to that equation. Okay. So moving on. Trial and improvement now. So this is one where we just need to remember how to set it out properly. All right. So this is where we do a table. So we say x, answer, and comment. Okay, it says it lies between 4 and 5, and there's the equation there. So always start with the numbers that it gives you. So we're going to start with the number 4. So you're just substituting number 4 into where these x's are. Okay, so it should be 4 cubed minus 7 times 4 minus 75. Okay, which for me was minus 39. That's less than 0. so it's too small. Then we try 5. So 5 cubed minus 7 times 5 minus 75 is 15. That's bigger than 0, so that's too big. That confirms what we were expecting anyway. The answer's in between those two. I would always try the middle number then, okay, because the answer could be 4.9, but if you start at 4.1, it's going to take a while to get there. So do 4.5 in this case, because it'll be a good indication of where you go next, whether you go up or down. Okay, so 4.5 cubed minus 7 times 4.5 minus 75 is minus 15.375. Okay, so that's too small. So obviously there'd be no point in doing anything smaller than that now. So just go from there, pick a number from there that's bigger. I'm going to try 4.8. Okay, so 4.8 cubed minus 7 times 4.8 minus 75. So that gave me 1.992, which is too big. All right, so we need to find out now. Just need to double check whether 4.7 is too big or too small. All right, because then we can go from there. So now I'm going to do 4.7 cubed. Take away 7 times 4.7, take away 75, minus 4.077, too small. Okay, so from there now, 4.8 is too big, yeah. 4.7 is too small, so it has to be in between those two somewhere, doesn't it? I know we only want it to 1 decimal place, but we've got to show now which one of these two it is. So in between those two numbers is 4.75. So this will tell us now whether we should be rounding up or down. So do 4.75 cubed minus 7 times 4.75 minus 75 equals, and I've got minus 1.078125. Okay, that's too small. So that means anything smaller than that is also too small. So the answer must be 4.8 once we round it up. So x equals 4.8 to 1 decimal place. Okay, and if I just quickly do a number line to show you, we've said that 4.7 is here, 4.8 is here, 4.75 is here. Okay, that's too small, that's too big, that's too small. So that means the answer really must be somewhere in between these two, mustn't it? Yeah, but any number that you pick in there anyway, when you round it to 1 decimal place, it's always going to give you 4.8. Any number in here, it doesn't matter how many decimal places you do, any number there, once you round it to 1 decimal place, is always going to give you 4.8. So that's why for this question, the answer is 4.8. Okay. Right, moving on. Simplifying algebraic fractions, okay? When we simplify algebraic fractions, just remember, all we do is factorize. So we factorize the top and factorize the bottom, okay? So factorizing the top of this, okay, would give me 2 and then x plus 8, because 2 is the highest common factor, isn't it? Factorizing the bottom, there's 3 terms, so that's 2 brackets, x and x. The end, look, is a minus, so we're times in to make a minus, which means it's plus and minus together. So 2 numbers, the times to make 8, and I've got a difference of 7. It can only be 8 and 1, can't it? Yeah. In this case, it's plus 8 minus 1 because we're trying to make plus 7. And you also know that it's got to be plus 8 because remember, for this topic, you should end up with the same bracket on the numerator and denominator. Because what we do then is cancel those 2 out, and our answer would be 2 on top, x minus 1 on the bottom. Okay, next. Same thing again, right? Factorize both of them. So top one will go into 2 brackets, x and x, okay? They're both positive. We're times in to make 18, add in to make 9. If you're unsure, list your factors of 18, but it's 6 and 3. Okay. Factorize the bottom, there can still be 2 brackets because, like we discussed earlier on, this is a square number. Okay. So it's going to be x plus something, x minus something. Square root of 36 is 6. So that's what we get. these two will cancel each other out. So it's x plus 3 on top, x minus 6 on the bottom. Right, moving on. So adding and subtracting algebraic fractions now. So adding and subtracting, it just says write them as single fractions. So we're not solving them like we did in some other questions before. So same rules apply as we said before. Adding and subtracting fractions, denominators have to be the same. So the only way we can make these denominators the same is just by multiplying them by each other. Okay, so if we multiply them by each other, let's just do it as a double bracket for now. So in this fraction here, we already had the x plus 2 on the bottom. So we've times it by x plus 1. Yeah, so that will be 3 times by x plus 1. In this fraction here, we already had the x plus 1 on the bottom, so we've times it by x plus 2. So we've got to times the top by x plus 2 as well. So we've got 5x and then x plus 2. Okay, and all we can do from there then is expand the brackets and try and simplify. Okay, so if we expand, we get 3x plus 3. Expand this one is 5x squared plus 10x. And expanding this bottom one, if you quickly were to do the box method, all right, x times x is x squared, 2x and another x is 3x, 2 times 1 is 2. And the only other thing you can do there is just try and rearrange this top, make it a little bit simpler and collect some like terms. So we've got 5x squared, okay, we've got 3x plus another 10x, which is 13x, and we've got plus 3 at the end, and the bottom then, x squared plus 3x plus 2. Okay, we can't simplify that any further, but we've done what the question has asked. We wrote that out as a single fraction. All right, so just use your normal rules for adding and subtracting. Okay, I'm just quickly now going to do the multiplying and dividing one, because I'm running out of time a little bit and I don't want to have to do another video just for one topic. Okay, so you can have a go at this one in the same way. I'm just going to quickly do these two to finish off. All right, so when we multiply fractions, just remember multiplying fractions is top times top and bottom times bottom. So that's exactly what we do here. All right, 3 times by 5x is 15x, and x plus 2 times x plus 1 is as the double bracket, isn't it? So all you do then is expand the double bracket, you get x squared plus 3x plus 2, and that's the answer. Okay, 15x on top, x squared plus 3x plus 2 on the bottom. So just remember to multiply two fractions, top times top, bottom times bottom. And then last one, this time it's dividing. Okay, so we need to remember to divide two fractions. Keep, change, flip. All right, so we keep the first one the same. We change the symbol from divide to times, and we flip the second fraction over. So instead of 5x over x plus 1, it's x plus 1 over 5x. Then we do the same as we did in part A. So times the top two together. That's 3 times by x plus 1 times the bottom two together. So that's 5x times by x plus 2. Expand the brackets. So 3 times x is 3x. 3 times 1 is 3. 5x times x is 5x squared. 5x times 2 is 10x. Okay, we can't simplify that any more than it's already done. So that's the answer. We've written it as a single fraction. Okay, so that's how we do it. All right, so there's lots on there. So have a look at the videos. Thanks for watching. Hopefully, you know, things will start getting back to normal a little bit. And yeah, I'll see you soon. Okay, so I will post a test as well at some point this week. But yeah, thanks for watching. See you soon. Peace.